Right, so we'll start how to draw a cost planning and monitoring. So how to draw a PV line, or also referred to as a budgeted cost of a work schedule line. So this was all to do with the planning, things that goes before execution. But today we will be focusing more on how we ensure that uh, when we have planned, we effectively monitor it, and if there are deviations from the plan, then we could introduce different sort of a control measures to put the plan back on track. So in this session, we will try to understand the concept of tracking project performance. We will understand project S curves and how they are used for management purposes. We will understand significance of earned value analysis, what it is, how we could use it both for small scale projects and large scale projects, and understand different project reporting systems. Uh, so there are a few tongue-in-cheek laws of project management. So starting with, when things are going well, something will go wrong. So in particular, in the construction projects, we have to be very proactive. And it's very rare that we have a project where everything is going well. Uh, there are so many risks and so many variables involved that one has to be ready for things going wrong. When things just cannot get any worse, they will. So once the downward spiral starts, then we see the cost getting out of control, the time getting out of control, and very often we have to make use of worst case scenarios. When things appear to be going better, you have looked something. So very often we attend these marketing styled presentation where we are often told that everything is in shiny, perfect order. But it's very much possible that we are overlooking something, and it's very much what's happening with the use of modern day software, which are very good in presenting uh, very flashy presentations, very good charts, graphs, and a skewed presentation of data, which may give us a very positive outlook, which may not be the case. And that's we see very often with a lot of mega projects where things go out. With a good plan, it will take you double the time. With a not so good plan, could be maybe 5 or 6 times more. So just make sure that what you plan is just a plan. Once you start implementation and execution, things may end up taking much more than what you originally estimated. And then how does a project get 1 year late and it one day at a time? So these are minor of issues which escalate to major problems. So this is just tongue-in-cheek illustration of things which go wrong, and the importance of monitoring and control. So, in terms of monitoring, this famous quotation by Rudyard Kipling, I keep six honest serving men, and they taught me all I knew, and their names are what and why and when and how and where and who. So, project manager must be using these honest serving men to ensure that what they have planned is also being delivered. And another uh, uh, statement from Hewlett: you cannot manage what you cannot measure, and what gets measured gets done. So we will see that in monitoring, the measurement is very important. Unless we have got a baseline, it's very difficult to ensure we are delivering. So the first concept which we will review today is a banana curve, or a progress S curves. We will learn how it is drawn and how it is used on projects. So the project S curves, this is an important engineering management tool. It provides a visual tool to track progress of a project. So one reason why it is so popular is like bar charts or Gantt charts. It's a visual presentation of a progress of a project. It allows project managers to quickly identify project slippages. So it helps us see two extreme situations based on the early and the late timings, and any slippages could be identified. Progress S curves plot cumulative costs rather than weekly or monthly costs. So we will see how these S curves are drawn. So here you can see an illustration of a network diagram which is showing you the logic of the project, and you can see all the early start and late start and slack calculations have been done here. Now we have gone through this case study previously when we were adjusting the resources. So here is a budgetary allocation for different blocks of construction which were taking place. So for instance, activity W has a total budgetary allocation of 45 grand, and it has a duration of 2 months. So an equal split across 2 months would mean that every month we would have a totally budgetary allowance of 22,500. Likewise, activity B has a budget of 192 grand, and it's split over 4 months. So that means that the monthly allocation is 48,000. Right, so we did discuss that we use bar charts to load our resources, and we can load our costs as well. So here we can see we are loading our costs on our bar chart based on the early start time. So the first activity here is W, which you can see is taking place from starting at the beginning of a project to second month, and we can also see that the budgetary allocation is 22,500 per month. So we have inserted 22.5. And likewise, activity K has a duration only of 1 month and is taking place from month 2 to 3, and that's the reason why we have inserted the total budget, which is 12,000 for this activity here. Activity B has a monthly allocation of 48 grand, and we have done it. So you would note that while loading the costs, we have made use of all early start times, and all the float is available. So based on the early start times, we have produced a cost loaded bar chart, and here we could see the monthly invoice which we will be producing. So in the first month our total spend is 22. In the second month we have 22.5 again. In the third month we would do accumulation of all these costs, and that's 96.1, and on the fourth month it's 132. And to plot the S curve, we would be using accumulative costs. So basically, by end of month one, we will be raising an invoice of 22.5 to the project client. Then by end of month two, it will be 22.5 add 22.5, which is 45, and end of month three, 45 add 96.1. 141. So we will be having a cumulative cost, and these cumulative costs are used to produce the S curve. So here, for instance, the first month it is 22.5 on the graph, the second month is 45, and by the third month we are crossing the first 100,000 payment, so it is 141. So mind you, this graph is plotted based on the cumulative costs and not the total cost. So this data is used to plot the cumulative cost, and you can see total budget for this uh, 174,200 pounds. So here we created this progress early start progress S curve, which basically reflects how we will be invoicing for this project. Right. So here you can see the first month invoice was 22.5 based on this value, and the second month invoice is 45,000 based on the second month, and the month invoice is 141, and so on and so forth. We have completed this, and that's the last invoice, which would correspond to the month 19 here. So this is often referred to as a S curve. So S drawn in some shape like this, where a low slope creates a slope on the side. So basically, this may include some groundwork, some foundations work. So we see that slope is indicating a slow progress, which means not a great deal of our contractors are involved at this stage, and also it also reflects on we are not spending too much money upfront. And then this is followed by usually relatively slope of a project, which indicates a lot of a rapid project, and towards the end where we have got finishing and handover of the project and commissioning, and relatively small progress. It's not a rule of thumb that all projects will follow this sort of a curve. There could be specialist projects which may involve deployment of some um, sophisticated machinery, which may mean that there will be a lot of expense towards the end of the project. But a lot of typical construction projects would follow this sort of a schema. Now, over here, we see some practices being used by contractors, which create some mistrust. Sometimes contractors overbill the owners without the physical work on site, and this practice is called front loading, where the owners, no, sorry, the contractors invoice for the work which has yet not been delivered, or basically this could create a lack of trust. They try to eat into the retainage which clients may be holding on. So it is important that the progress payments should be proportional to the amount of work that is being accomplished on the site. So far, we saw the early start S curve. The other possibility is to have a late start progress S curve. So it's just a variation of the example which you were seeing previously, but here one thing you would notice is that all the float is being used upfront, and the work is being done at the latest possible times. Now, this is obviously not a recommended practice because that makes the whole project very sensitive. So, for instance, if there is a delay in activity P, it's very likely that the project will not be able to meet its deadline, because here all the activities, even the non-critical ones, have become critical now because we have used up all of their float. So as a result, this is very sensitive, but we saw that projects do face different constraints. In one of the previous examples we did, the owners had some cash outflow restrictions, so they did have some sort of a constraint that they cannot make a progress payment any more than maybe 50,000 or 60,000. So you could have those sort of situations where you could possibly have to schedule all of your activities on a late start date, or some of the activities on a late start date. So here is an example of the chart which is drawn based on the, so here we have shown the total values but not the cumulative value. So the cumulative value will be calculated very similar to in the previous example, and then we will use the cumulative values to plot this graph. So here, things we have to remember is that work is taking place based on the late start and the late finish timings, and so you can see the difference it can make. First thing is that whether you do work on the early start or the late start, the total remains the same. So there is no variation in the total spend. However, the uh, amount of outflow from a client's perspective is a bit front loaded in the earliest timing. So for instance, if we compare by end of third month in an early start chart, the clients have to uh, pay 93,000 in a late start situation, whereas their payment in case of an early start is 141,000 pounds. So there is a bit of a variation based on the constraints. One can see what suit different situations. Right, so basically the banana curves are created by overlaying the early start project S curve and the late start S curve. And these are referred to as the project S curves or banana curves because usually it resembles shape of the banana. Right. So how they are used? A lot of time. The once we are dealing with portfolio of projects, so not an individual project, but we have got a number of different schemes going on. Very often executives use what is called a management by exception, where they will like you to report your actual progress of the project uh, on a regular basis, and they will expect that this progress line must stay within the two. So for instance, your actual, so this is what is your planned uh, spend based on the early dates, and this is your planned spend on, but they would like you to report uh, your progress. So this is could be your actual spend line, and if the actual spend line is falling within the curve, then that's absolutely that is considered okay. But if you get into a situation where your actual spend line is falling beneath or going above the this area within the chart, then it triggers what is referred to as a management by exception, because the rule of thumb is that your actual progress line should stay within these two situations. So any transgression would trigger a response from your senior management, and that could trigger a review of why you're underspending so much in this case, or overspending. So it also serves as an early warning system, and it is considered a good tool by various senior executives who may have to monitor a portfolio of projects, so a number of different projects taking place. So it may not be possible for them to go to at a level of each a block of construction, look at the cost of that data. Rather, it gives them a big picture overview of how things are progressing, and where there is an exception, where things are falling beyond these two lines, it triggers a different review. So in terms of a software and their capability, as far as I know, a Microsoft project or SureTrack cannot generate these curves. However, Primavera have the feature which allows you to generate these curve. Right. So there is a 5D model, which is also you can access it by clicking. So you can access the file, which you can download. It's just a demo version from Vico software. So in this model, the reason it's called 5D, it has got the 3D model, and it is information rich. So once you click on any component, you would see details of how it is constructed, and a little bit information about the construction method and technique. But also, it has got some cost information, and it has got this time information, the Gantt chart attached. So it gives a very good overview, and that's the way we are heading within our industry, trying to integrate these different dimensions so that we can have a better control over our project. Right, so we may explore it in a bit more detail, but here you can see the three uh, terms which are often used very frequently when we talk about monitoring, and these are basically three different lines. So the first you can see is budgeted cost of works scheduled, which is also referred to as a PV line, and we learned how to draw a PV line previously. So this is basically tell us uh, what should be our planned spend. So according to the original plan, what should we spend? The other thing is this ACWP line, which refers to as so ACWP is for actual cost of work performed. So what is the actual spending on the site? And BCWP is also referred to as a EV line, earned value line, or this is basically based on the actual cost of the work which has been performed. What is the value of the work which you have accomplished, right? So, so we will come to these points a little bit later in our presentation, but you can just download it and explore this model once you have the time. So very often when using a software, we use the baseline and a tracking Gantt chart. So you can see the baseline Gantt chart is indicated by this pink color here, and tracking Gantt chart basically allows us to track progress through various period of time. So we will be regularly, maybe on a monthly basis, we will review. So here we are tracking the progress of a project at end of month 6. So you can see the timeline running at the bottom, and we are reporting the progress. So you are being asked to comment on the health of different activities. So in terms of activity A, would you be satisfied with the progress being made on activity A? Looking at this Gantt chart, so we can see uh, on the top the baseline duration is given and the actual completion. So we are on track on activity A. There is nothing to worry about. Likewise, for activity B, the plan was to have complete activity B from month 2 to 5, and the actual delivery is just mirroring what was planned. So again, activity B is on track, and so is activity A. There is nothing to worry about. Activity C, if you could see, um, would you be worried about activity C? Or so activity C is actually ahead of schedule. So it was supposed to be completed in the 4 months, and we have already completed. So this is an example of an activity which is uh, ahead of schedule. So we have done better than what was expected. Now, reflecting on activity D, it was supposed to take 3 months to complete, and we have started work. So we are reporting on month 6. However, the site staff are saying that this activity would take slightly longer, so remaining duration. So this activity is taking slightly longer than it was supposed to be completed in 3, but based on the forecast, this activity will now take place in 4. As a result, we can see the original project deadline 12 months. However, because of delay in one of the critical activities, this has a knock-on impact, and it will be completed in the 13th month. In terms of progress E, we can see we have an early start. It was supposed to start after month 6, but we have started here on month 5, and it was supposed to take 1 month, but uh, this zigzag indicates the remaining duration, so it is now going to take 2 months, but there is some float still there, so it is going to have no impact. But right, so most of the software do allow you to create baselines, and then you can use it to track using these baselines. Right. So having reviewed different strategies which are used for planning and monitoring, so we started with banana curves, and then we reviewed a little bit about baseline and tracking Gantt charts. We may touch upon it a little bit later in more detail in the following sessions. Thirdly, we will review the concept of earned value analysis. Now, different authors use different terminologies. In certain books, you will see this as being referred to as a cost schedule control system criteria, and very often used in public sector projects for reporting progress of the work which is being accomplished. Now, we will discuss the concept slightly later, but before that, we will like to have this example. So development of a new housing colony is to be completed in months with a total budget of £4 million and at a cost of 400k per month. So 4 million over a 10-month period. So we have come to a monthly spend of 400,000 per month. Now, planned cost for first 5 months was £2 million. This planned cost is also referred to as a planned value or budgeted cost of work schedule. So, however, the actual which, if you are using a software, the term we use is actual cost of work performed after 5 months was £2.4 million. Right. So, how would you comment on the progress of this project? Would you be satisfied? Would you be not satisfied? Or would you think that there's not sufficient information here to make an informed judgment? Right, so this is the planned value line. So the total planned cost is £4 million. This is the reporting period, right? So after 5 months since the project started, we are reporting, and this is the planned spend line. According to the planned cost, we should have spent 2 million, but actually have spent 2.4 million pound. So would you be worried about this, or would you not be worried about it, or would you need more information to make a judgment on the progress? Right, so there's a bit of a question mark here. This 0.4 million pound overspend, right? So we know this, there is an overspend, but we do not know where this 0.4 million pounds has been spent. It may be possible that the project managers are very proactive. They are delivering all the work ahead of schedule, and it is very likely that they are to complete this project in 8 months time. And even though their cost curve is looking slightly high, uh, but it is indicating project progress which is very healthy. Or it could be a situation where a project is really falling behind schedule. It is going to cost. However, without having any idea about physical progress has been accomplished, just relying on the planned spend and the actual spend could lead you to a misinformed judgment. So very often we look at oh, this is the plant value and this is we have overspent by 0.4 million, so there's something definitely going wrong. But there's not sufficient information here. We have to, the missing piece in the puzzle is the progress. What actual progress has made on site. Without this progress, we are not in a position to make an informed judgment, right? So it may be a case that we, even though we have overspent, but we could complete our project slightly ahead of schedule, or it could be a case that we uh, we could go over budget. But without any information about the planned progress, we cannot make any informed judgment. So here is a bit of a variation of the scenario. Developing a new housing colony is to be completed in 10 months with a total budget of 4 million and a cost of 400,000 per month. Planned cost for the first 5 weeks was 2 million pound. Now actual spend after first 5 weeks was 1.7 million pound, right? So on the face of it, this looks of a underspend, 0.3 million pound underspend, right? Again, without any idea about the progress that has been made, we cannot make a judgment. It could be that we are ahead of schedule and we are saving some money, or it could be we are really behind schedule. So so the point being made here is just relying on the planned cost data and the actual spend data is not enough. We need to have a third component here, which is the actual progress that has been accomplished on site. So if you recall, we did learn about how to draw a PV line. If you use a planned value line, if you use a software, you will be using a term called BCWS, which means budgeted cost of work schedule. So we learned in our previous lecture how to do this line. So the point being made here is merely relying on the planned funds and the actual cost spent data may provide you with the false and misleading information. And it is very important to associate the cost spent with the physical work that has been accomplished. So for effective project control, you must map the time phase cost to project schedule. So if we compare the traditional management approaches, they relied on two key data sources, the budget or planned expenditures and the actual expenditures. The comparison of budget versus the actual expenditures merely indicate what was planned to be spent versus what was actually spent at any given time. It doesn't have this component of production attached to it. So it didn't look, it just looked at what was actual spend or actual work accomplished, what was planned. So that was the only basis of decision making. Now, with this approach, there is no way to determine the physical amount of work performed. It does not indicate anything about what has actually been produced for the amount of spent, nor whether it is being produced at the rate or according to the schedule originally planned. In other words, it does not relate the true cost performance of the project. And this is the reason why we have seen use of earned value technique, which is now widely used. So in earned value management, which is a systematic approach to the integration and measurement of cost, schedule, and technical scope accomplishments on a project or a task, it provides both the government and the contractors the ability to examine detailed schedule information, critical program and technical milestones and cost data. So in most of the public sector projects across the world, we make use of earned value techniques. Now, with anything coming from the government, it has have a use of too many terminologies and too many terms. So we will be getting exposure, but just to warn you that there are too many terms involved in typical earned value management system. So earned value management is intended to provide data from a contractor's management system to the government in a standard data analysis that relate time-phased budgets to the contract tasks. It integrates cost, schedule, and technical performance. It indicates work progress objectively, are valid, timely, and auditable, are from the internal systems of the contractors and users to manage and at a practical level of summarization. So we'll start by looking at a simple example of what earned value analysis is and how it is used. So let's assume you have got a garden and you want the grass neatly mowed like this. So you do a contract with the gardener, and the contract is that you will pay £100 per day of effort, and the contractor has estimated that it will take 1 day to clear the garden and to sharpen it. Right, so you view the progress of the work after half a day of the contractor working, and you see that 50% of the work has been completed. So it looks like this is going to be a project which is going to be on budget, right? Because and on schedule. So if we look at earned value, the formula for is earned value is a percentage complete time budget. So 50% of the work has been completed on half day, and multiplied by 100 would mean that the gardener or the contractor has earned £50 of value at that point. If we take another example here, so you check the progress of a contractor and you see that after half a day, only 25% work has been complete. So in this case, the earned value of the contractor is £25, and it is likely that if the same um, progress is made, your project would double. So your project total cost will be £200 because you have had a count of £100 a day, and the project will not be completed in 1 day, but it will be a 2 day activity. So this is going to be a project which will be over budget and behind schedule. The third situation is that you look at the project, and after half a day, the 75% work has been completed. So as your contract is £100 a day, it is likely that your project will be under budget, because as the work is completed in less than a day, we'll have to do less payment and it will be ahead of schedule. Right, so we will come to it and we will do a few more examples on earned value reporting to get our heads clear on how it is. Now here is a snapshot of practice. So it reads that when Bill Gates was in charge of Microsoft project teams, spent report each month to top executives as well as the managers of all related projects. The status reports were brief and had a standard format, right? So when we are managing a portfolio of projects, it is important to have developed standards to see how work is progressing. So Gates read most of them quickly and spotted potential delays or changes he did not want. He especially looked for schedule slippages, cutting too many product features, or the need to change specifications. Um, Status reports are an important mechanism for communicating between top management and the project report. So here is a quote from Bill Gates: "I get all the status reports. Right now, there may be 100 active projects. The status reports contains the schedule, including milestone dates and any changes in spec and any comment about how we cannot hire enough people or some technical issues. We are just going to have to totally slip. They know their report goes to all people who manage all the other groups that they have dependencies. So if they do not raise in their status report and then 2 months later they say something, that is a breakdown in communication. Internal group is totally copied on these things, right? So Bill Gates is often cited as one of the very good managers who led Microsoft to its success. Right. So In terms of earned value, um, very often we um indicate the progress made on a graph, and there are certain terms which we indicate. So here, and the first one which we will see is the PV line, and this is the planned value. So this is the what was originally planned in the project, right? And this BSC indicates the budgeted cost at completion. So we can see that the total budget for this project was 400K, right? Now, this ACL is the actual cost line, and here you can see this project is being reported on the 25th day of this project, and we can observe here that the actual cost spent to this date is 340, which compares to the planned spend of 300. So according to the plan, we should have spent this much, but we have spent 40,000 extra. Based on this, we can extrapolate it to do the estimated cost at completion. So this project, which was originally supposed to take 400, if we continue at this progress, I think we can read it as maybe 470K, right? So, and also it was supposed to be completed around 45, but now based on the work which is being reported on the day 25 of the project, it will take 5 more days, so 70,000 over budget and 50,000 sorry 5 days late. And the third line that you can see here is the earned value line, which is basically indicating that against the cost which we have spent. So we have spent here 340, and the total value of the work that we have actually accomplished is uh, is actually 200K. So basically, we have spent 340K of budget to accomplish a work which has a total value of 200,000. So I think just by having a look at it, it is not looking good. So on the y-axis, we can see is the cost, and on the x-axis, we can see the time duration, right? So we use this term which is called schedule variance, which tells us how are we performing in terms of time. So this gap between the and it is usually calculated by finding a gap between the PV line, which is this one, and the this bottom line, which is called EV, or also if you are using a software, we refer to it as a budgeted cost of work performed. So schedule variance is telling us that basically, so there is the value of a schedule variance. If we do this is 200, 300, so it is 100. So in terms of a schedule, we are falling behind 100,000 pounds of or dollars of work. So we and this basically indicates the cost variance, which is a difference between the actual cost and the earned value. So in terms of a cost, how we are performing. So just by looking at a very simple graph, you can see we can extract a lot of information. For instance, the total budget of this project, what is the total duration, what is the estimated time to complete, what is the budgetary completion date as per original plan, what is the estimated cost at completion based on the reporting period, how well we are performing in terms of a schedule, we are performing in terms of a cost. So just using a single graphic, we can extract a lot of information, and that's why this is a very popular tool for executives to have overall overview of progress of a project. So here we can see different sort of earned value analysis charts being plotted. So when we do the cost variance, we use this formula, which is earned value minus actual cost, and the schedule variance we calculate using this formula. So basically, the rule of thumb you have to remember is that if the answer is a positive, it is a good news. So it means either your project is under budget or ahead of schedule. If the answer is a negative, it basically indicate you are overspending or you are falling behind schedule. So positive is a good news, and negative variance is usually a bad news, and bigger the variance, the worse it will be. So we could end up in number of different situations. So here you can see the first one, where this is the plan value line. We have actual cost is on top of the plan value, so we are spending more. So we can see our cost variance is negative, because cost variance is earned value minus the actual cost. So we are earning much lesser than what we are spending. And the schedule variance, which is calculated by earned value, take away um, the plan value. So we can again see there is a huge gap here between plan value and earned value, leading to a negative answer. So this is a project which is doing bad in terms of a time, poor performance, and both in terms of a cost, poorly performing. Here we see the second graph, where this is the plan value line, and this is the actual cost. And here we could see that in terms of a schedule variance, it's a positive answer. So in terms of a schedule, we are ahead of schedule. However, in terms of a cost, we are spending more than what is expected. In the third graph illustrated here, you can see that this is the plan value line. We have actually spent slightly more than that, but you can see the earned value graph, which is much higher than so there is a great deal of a variation here. So we have uh, accomplished much more, and because of it, this difference, the cost variance is positive. So this is an example of a project which is ahead of schedule and is also underspending. Whereas in the last example, we see that we are actual cost is much lower than the planned value cost. So in terms of a cost, we are doing very well because we are spending less. But in terms of a progress, also we are making small progress. So in terms of time, we are doing negatively on this, but in terms of a cost, we are doing positive. So we saw reviewed different earned value analysis graphs in cost scheduling system for project monitoring. It is an integrated project management system based on the earned value concepts that uses a time-phased budgeted baseline to compare the actual and the planned schedule and costs. And it is pioneered by the governments and used by a lot of public sector reporting. As a result, it has got too many terminologies and too many abbreviations that you have to keep in mind. So it's a way of measuring overall performance, not that of an individual task. Is using an aggregate performance measure, which is earned value. Earned value of work performed or value completed for those tasks in progress found by multiplying the estimated percent physical completion of work for each task by the planned cost for those tasks. The result is amount that should be spent on the task so far. This can be compared with actual amount spent. So in earned value management, unlike in traditional management, which relied only on the planned versus actual spend, there are three things. So budget, or the planned value of work scheduled. This is also referred to as a budgeted cost of work scheduled or planned value. The actual cost of work performed, if you're using a software, it will use a term actual cost of work performed, or the earned value of the physical work completed, which is referred to as budgeted cost of work performed. So this is, mind you, of work scheduled, and this is performed. So earned value takes these three data sources and is able to compare the budgeted value of work scheduled and compare it to the earned value of physical work completed and the actual value of the work completed. Right, so here in this example, budget line is below both the actual expenditure and the earned value line. So what does this mean? So here we can see that on this project, this is the PV line, or budgeted cost of work schedule line, and by this is the project started in January, and this is reporting in June. So we should have spent 30,000 by in this month. In terms of the actual spend, so this was what was planned, and the actual spend is 60,000, and the earned value is here 45,000. So we have spent a bit more, and we have earned 45,000 pounds of work. So the project budget is total in total 60,000, and based on this progress which is being made, we can have a forecast, and it will indicate that in comparison with 60 grand original budget, we are heading to almost double this based on the extrapolation. So this is the actual cost line, project spending. This is also called as actual cost of work performed line. This blue line, this blue line is the actual cost of work, and this black line here is referred to as earned value, or budgeted cost of work performed. So we can see here project is spending more than it was budgeted to date. The project should have tried to stay close to this red line, but we have spent much more than it was, and even though we have a project is producing more, so even though black is slightly the actual performance line is higher, but our actual cost spend is much higher, which is leading to our forecast of an increase in the project. Right, so I think we will come to these slides at a later date. We will do two small case studies. The first one focusing on the application of earned value analysis on a small scale project, and secondly, uh, application on a slightly large scale project. So here the scenario is that your employer would like you to look at the project manager's notes taken on Saturday, October 28th. So the calendar is given here, and this is the reporting period. So we have to report progress of this project on this particular date, assuming that the project is executed 5 days a week and 8 hours a day, with some additional non-working days which are denoted with bold letters and underlined in the calendar. So there's few public holidays which are indicated. So for instance, this is a bank holiday. So project managers tables of activities is shown below. So here you can see there are different activities in this project. So firstly is the site preparation activity. The original duration was 8 months. The actual duration has been 9 months. So it has taken 1 month more than what was planned. The actual start date was 27th of February, and the actual finish was 28th of April. And as we are seeking input on 28th of October, we are being reported that on this reporting date, which is 28th of October, 100% work has been completed. The original budget for this activity was £500,000, and the actual expenditure has been 600,000. So we can straight away see that they have overspent uh, around £100,000 on this activity. The second activity was substructure, which was supposed to take 12 weeks. Actually, it was completed in 11 weeks. It was supposed to start on 1st of May, and actual finish date was 18th of July. And on the reporting date, which is 28th of October, it has been completed 100%. The original budget was 1.5 million, and it has been accomplished in a slightly lesser budget of 1,350,000. Now, the question asked here is forecast the duration of the activities that are currently in progress, assuming that their current rate of will continue till end of the project, and also find out the remaining duration as per the forecasted duration. So the keywords here is um, that are currently in progress, right? So can I ask you to look and identify activities which are currently in progress on 28th of October, which is the reporting date. So we can see one thing clearly, that this activity has already been accomplished. So this is not an activity which is in progress. Substructure is an activity which is already been completed. So this is not an activity in progress, it has completely been completed. On the reporting date, superstructure is an activity which is in progress. That's why indicated by 75. Exterior is an activity which is not in progress, it has yet not started. And interior is the second activity which is in progress. Right. So we look at, so they are asking this, it's asking find out the remaining duration as per the forecast. So how much further time would be required to complete superstructure? Right. So it's just a simple case. We could look into that this activity started on 20th of July. So this is where this activity started. And we can see that we have accomplished so from 20th of July to the current reporting date, which is 28th of 10, we have accomplished 75% of the work. So we can extrapolate it to compute how much remaining time it would require. So let's see how many weeks have passed since this activity started. So as it started on 20th of July, that is 27th of July is the first week. So second week, third week, fourth week, fifth, sixth, seventh, 8, 9, 10, 11, 12, 13, 14. Right, so 14 weeks and 1 day, but also we have got a I think a holiday here. So we can say that it has taken us 14 weeks to deliver 75% of the work. Right, so any guess how much it would take us to do um, deliver 100% of the work? Right, so simple percentage calculation. So 75%. Yes, that's right. So basically, 75% work is delivered in uh, 14 weeks. So 100% work will be uh, delivered. So we will just do 14 divided by 14 divided by 75 multiplied by 100, so it will give us a figure of 18.67 weeks to complete. So our manager is asking us find out the remaining duration as per the forecasted duration. So of these 18.67 weeks, 14 weeks have already elapsed, so our guess will be that this activity will take 4.67, or we can round it, so additional 5 weeks will be required to complete this uh, activity, right? And likewise for the other activity, which is interior, uh, interior started on 31st of August, and we have delivered 50% of the work to this date. So just looking at the calendar, it started at this point, and if we start calculating the weeks, so it will be 1 2 3 4 and 5 6 7 uh, 8 weeks, right? So any guess on how long will it take us to complete this activity? We have taken 8 weeks to deliver 50% of the work, right? So it will take another 8 weeks to completely deliver this activity. So the total duration is 16 weeks, based on, so it will so we can give an answer that for this activity, further 8 weeks are required to complete this activity, right? Now the other thing which is required is calculate the planned value, or also known as budgeted cost of work schedule, based on the original budget, the original duration, and the number of weeks between the planned early start and the status date for the activities that are in progress. So they're basically asking you how much money we should have spent to this date for the activities which are in progress. So you can see that the total budget for this activity is £2 million, and you can also see the total duration of this activity is 18 weeks. So basically, over a 18-week period, we should have spent at 2 million. That is the budget. Right now we are on the 14th week, right? So in the 14th week we should have spent how much? So it will be 2 million divided by 18 multiplied by 14, right? Which will give you an answer. So roughly around maybe 1.55 million pound should have been spent to this date. Similarly, we can look at the other activity, which is interior, where the original budget is 1.8 million pound, and the total duration is 14 weeks. Right, and we know that at this point of reporting, we are in the 8th week. So we are in 8th week. So we know that over a 14 weeks period, the budgeted cost of work schedule was 1.8 million pound. So we are interested in calculating how much we should have spent by 8th week of the project. So by 8th week, we should have spent 1.8 million using a simple percentage or a proportion rules for 14 multiplied by 8, right? Which should give us a value, right? So if we use the calculator, it will be something like a 1.028 million pound should have been spent. So we should have spent this much amount of money at this point of reporting. We further continue to respond to the information which is required. The third thing is calculate the budgeted cost of work performed, which is also referred to as earned value, based on the original budget and the actual work complete for the activities that are in progress. So the formula that has to be used is earned value is simple percentage complete times planned value, or budgeted cost of the work, right? So we are being asked to calculate the earned value. So the first activity which is in progress is this superstructure. And if we look at what value we have earned, so the total original budget of this job was £2 million, and we have accomplished by the reporting date of 30th of October, which is this reporting date, and we have accomplished 75% of the work. So it's a very simple case. 75% of £2 million, right? So this is about 1.5 million pounds. So earned value for superstructure is 1.5 million. We have accomplished 75% of 2 million, which comes to 1.5 million, right? So the other activity is interior. By the reporting date, we have been told by the site staff that they have accomplished 50% of the work. So 50% of 1.8 million would mean that the earned value for interior works will be 50% of 1.8 million, which would mean 0.9 million pound is the earned value of the work that we have accomplished to this date. Thirdly, the manager is asking us to calculate the schedule performance index and the cost performance index, which basically tells us how we are performing in terms of a schedule. Are we ahead of schedule or behind schedule? And the cost performance index based on the BCWS and BCWP, which we have calculated in step 2 and 3 previously, and comment whether we are ahead of schedule or behind schedule, are we under budget or over budget. So the formula for calculating SPI is EV divided by PV. So first of all, you will look into this activity, which is superstructure. So the formula is of a schedule index. The formula is BCWP divided by ACWP, and by the way, we have calculated it previously. So we know we have calculated the budgeted cost of work performed in this step previously. So for this, the budgeted cost of work performed for superstructure is 1.5 million, and the actual cost is given here, so is 1.45 million. All right, so we bring this value at the denominator here, which gives us a schedule index of something very close to maybe 0.9 something, maybe 0.96. Now again, a rule of thumb is if it's greater than 1, if it exceeds 1, it is usually a good news. So 0.96 would indicate, and a value very close to 1 indicates a small variance. So in terms of a 0.96, it indicates we are slightly behind schedule, not too much. And the other thing which we have to calculate is the cost index. And the cost index uh, we will calculate for superstructure using the formula which is given here. It is earned value divided by actual cost of work performed. So we know that the earned value for this second activity is 50% of 1.8 million pound, which means that we have earned a value of half of 1.8 million, which uh, and the actual cost of work performed is so so I think, sorry, in this case the earned value is budgeted cost of work performed would be 1.5 million, which is we have calculated in the previous thing, and the actual cost of uh, sorry, I got mixed up a little bit. In terms of a superstructure, we are calculating the cost index. So budgeted cost of work performed was 1.5 million pounds, and the actual cost of work performed is 1.45, which will give us an answer 1.034, which indicate that the activity is slightly behind schedule and over budget. And then we will repeat the same for the other activity in progress. So looking at the interior activity here, for the interior, first of all, we will calculate the schedule index using the formula, which is budget cost of work performed divided by budgeted cost of work schedule. So here we can see the budgeted cost of work performed is 50 is 0.9 million pound, 50% of 1.8 million, and budgeted cost of work scheduled, which we calculated in the previous, was something like 1.028, which gives us an answer of 0.875, which is slightly less than 1. So we will comment that the activity is falling behind schedule. And in terms of a cost index for this activity interior, it will be calculated using the formula which is given BCWP divided by ACWP, and the budget cost of work performed here in this example is 900k, and the actual cost of work performed is from here. So in terms of a cost index, again, it is less than 1. So a value less than 1 means that this is a project which is behind schedule, and zero point 0.9 indicates it's a project which is slightly over budget, right? So 0.9 is close to 1. If it is 0.6 or 0.5, then we will say it's substantially running over budget. Right. So in this example, we saw how we could use this earned value analysis concept on a smaller scale project. Now we will do application of it in a slightly larger project. Now here, this is referred to as a problem set 3, where an expectation that there will be an evidence which has to be provided that you have understood it. So we will be discussing a solution to this, but in just uh, an explanation of different steps will be good. So hospital construction project with following activities and initial budget. So we can see in this project there are 5 different blocks to be constructed. The first block was to be starting in month 1, finishing in first month. Second one was second, finishing in third, and one was second to fourth, and the total BSC stands for uh, um, budget at completion of a project. So for activity 1 it is 100,000 to 400 and 1200, 600, and the total budget for this project is 2500 thousand pounds. Now we have been reported progress of a project at end of month 4. So it has been reported that activity 1 by end of month 4 has been completed 100%, and the actual cost of work performed has been 100,000. So we can compare it. That was the budgetary allocation, and by end of month 4 we have been told that the total spend is 100, which is fine. For activity 2 it has been completed 100%, and the total actual cost of work performed is 500, and we can go back and compare it. The actual budgetary allocation was 400k, so we just by looking at it we can see clearly we have 100k overspend on this activity. For the third activity, the it has been completed 75%, and we have already spent 1100 by end of month 4. If you go to original allocation, it should have been completed by end of month 4, and the total budgetary allocation was 1100 1200. So just accomplishing 75% of the work at 1100 indicate that we are heading for a cost overspend. And activity 4 we have spent we have completed 25% at a budget of 200, and if we compare it with allocation for activity 4, it was 600 total, right? So so you're being asked to estimate the cost at completion of this project, right? So the initial budget for this total job was 25,000 pounds, and what would be the estimated cost at completion based on the progress which is being reported by the site at end of month 4. Now, within earned value analysis, we come across different definitions, and we will review these definitions. So first one is BAC, which stands for budgeted cost at completion. So it is the original budget for the job, and it does not include the profit. So this is what was actually planned. PC, or percentage complete, is at the reporting time how much percentage of the work has been completed. Usually you would have maybe representatives of the client or independent person who would validate how much work has been completed if the payment is based on the progressive completion of the work. So percentage complete is a measure of the activity's performance and the progress to time now. The third thing is budgeted cost of work scheduled. The budgeted cost of the work that should have been done at any given point in time. And we continue with our definitions, as earned value analysis has got a bit of a definition overload. BCWP, or budgeted cost of work performed, which is the budgeted cost of the work that has been done at a given point in time. It is also called earned value. So based on the work that has been accomplished, what is the value that has been earned? And the formula which we use is percentage complete times budgeted completion of the activity, right? So for instance, if your total budget was £100 for any job and you have accomplished 55% of the job, that means your budgeted cost of work performed, or your earned value at that point, will be £55. Then actual cost of work performed, this is the data which could be obtained from the accounting system, how much we have spent on this activity, which is the actual cost of the work that has been done at any given point in time. We use all of this to calculate the schedule variance, which is which measures the time deviation between the actual progress and the planned progress using this formula. And if it's a negative value, it basically tells us that our project is falling behind, uh, and it is, if it's a positive answer, it tells us we are ahead of planned progress. And it is often referred to as a percentage, which is calculated by schedule variance divided by budgeted cost of work schedule. The other thing is cost variance, which basically gives us an idea about how we are performing against our cost targets. It's a deviation between the earned value and the actual cost of doing the work. The formula to calculate cost variance is BCWP minus actual cost of work performed. If it's a negative, then basically it's indicating that our final cost will be higher than the budgetary cost at completion, and if it's a positive, it's is telling us we are heading in lower than this. It's usually referred to as a percentage, and then it is used to complete estimated cost at completion or revision of the project cost. So uh, in the earned value analysis, we go through uh, this process. Firstly, we set up a table, then we calculate the budgeted cost of work scheduled, and we record the percentage complete and actual cost of work performed. And we calculate the budgeted cost of work performed using a formula: budgeted cost at completion multiplied by percentage complete. And fifthly, we determine actual cost of work performed to the time now, and then we use this information to calculate schedule variance percentage, cost variance percentage, and earn asset cost at completion. And then we plot variance to show the project trend. So we will go through this example, and then we apply control measures. We investigate activities where there are significant problems. Right. So firstly, we will start by calculating BCWS, or budgeted cost of work schedule. So for the activity one, we were given in a previous slide the uh, total budgetary allocation was 100,000. For activity 2, it was 400. Activity 3, it was 1200. Activity 4, it was 600, and activity 5, it was 200. Now, in terms of how these funds have to be used, we were told that activity 1 would start in first month, finish, so all the money will be spent in the first month. Activity 2, we were previously shown the timeline or the bar chart, which basically meant it would start in month 2 and finish in month 3. So our monthly spend would be 200,000 in month 2nd and 3rd. Activity 3, it is 1200, and we will be spending 400 in month 2nd, 3rd, and 4th. Activity 4, so this has been given, this information has been provided through the project bar chart or the timeline which has previously been mentioned. So this is the planned spend. So we can see the total project budget is 2500, 2500, of which we would be spending 100k in the first month, 600 in the second, 600 in the third, 700 in the fourth month, 300 in the fifth month, and 200 in the last month of this project. Right, so mind you, this should be 100. All right, now we are reporting the progress, so let's call it month, not year. So we are reporting the progress of the project at this reporting period by end of month 4. So how much money we should have spent? So we should have spent 100k on activity 1. We should have spent a budget of 400 on activity 2. For activity 3, we should have spent 1200, and for activity 4, by end of month 4, we should have spent 300, right? So this is our reporting period, and we should have spent 100, 400, 1200 and 300, and we should have spent any money on activity 5 because all the spend is going to take place on month 6. So we are reporting at end of month 4. So this is how we calculate the budgeted cost of work schedule. So according to the scheduled work, we should have spent this much amount of money by end of month 4, right? So this is the table which we use to complete our earned value analysis calculations and to identify estimated cost at completion. So mind you, you have been told the total budget of this job is 2500, but based on the progress which is being made, we will estimate what is the total cost at completion. So the first activity is identify what is the budgeted cost at budgeted cost of completion. So this has been provided in the question. So for the first activity, the total budget was 100. For the second activity, 200, 400. For the third, it was 1200, 600. So this has been given as part of the problem. So what is the amount of money we should have spent by end of month 4? And we have just calculated it in the previous step. So we have find that activity 1 should have been finished end of month 4, so we should have spent all the money on this. Activity 2 should have been finished by month 4, and we should have spent all the money on this. Likewise for activity 3, we should have spent. So mind you, we are just copying the value which we just calculated here: 100, 400, 1200, 300 to this table here. The third column here in our earned value analysis calculation is telling us what is the percentage complete. So again, this was given previously by our site staff that by end of month 4, which is the reporting period, activity 1 has been accomplished 100%, activity 2 has been accomplished 100%, activity 3 is in progress, having been completed 75%, activity 4 is in progress, having been completed 25%. So the next thing to do in this table is to calculate the earned value or budgeted cost of work performed. So this is very simple. We just see what we have accomplished, which is 100% of um, total budget. So 100% of 100 will give us 100. Uh, so basically, percentage complete multiplied by budgetary cost at completion. So 100% of 400 mean that we have earned a value of 400,000 for activity 2, whereas for activity 3 we have just accomplished 75% of 1200, which is 900, and for activity 4 we have just accomplished 25% of 600, which sums to 150. And activity 5 has yet not started, so our earned value for activity 5 to this point is 0. The next column here is ACWP, or actual cost of work performed, and this is the data which will be provided earlier. This is the data which will be provided by the site. So they are telling us that after month 4 they have spent 100k. So I think it's looking good because that's what was the plan. So this was what was planned, and this column is what is the actual spend. So here you can see, just by having a look at it, we have can see very clearly we have 100k overspent on activity 2, and activity 3 we have at this moment 100 underspent, but also we have to keep in mind that this work is just completed 75%, and likewise for activity 4 we can see the actual spend is 200 versus the total allocation of 600, but we have just accomplished 25% of the work. The next column is to calculate the schedule variance. So how do we calculate schedule variance? The formula is given here. Sorry, and this is the formula: BCWP minus BCWS. So basically we will take this column and we will subtract it from this column. So 100 take away 100 is telling us that 0. So in terms of a schedule, we were expected to deliver it in by within the first 2 months. We have already done so. Schedule variance is shown as 0. Over here, BCWP 400 minus BCWS 400 is giving a schedule variance of 0. Um, here BCWP is 900 minus 1200, which is basically giving us a schedule variance of minus 300, and here minus 150. Now we often represent it as a percentage using this formula, which is schedule variance divided by budgeted cost of work schedule. So we take the values of this column, which is minus 300 and 300, and we will divide it by this BCWS minus 300 divided by 1200, which will give us a minus 25%. So in terms of a schedule, it gives us a percentage. We are like a falling 25% behind, and likewise here we will calculate schedule variance as minus 150 divided by budgeted cost of work schedule. In this activity was 300. So minus 150 by 300 will give us a minus 50. So this is represented as a percentage figure. Right, so we can see that two of our answers are negative, basically telling us that we are falling behind schedule uh, in terms of activity 3 and 4. But we will also need to monitor the health of these activities based on the cost information. So the formula for the cost variance is PCWP minus actual cost of work performed. So this is answer. So if we look at, for instance, minus 100, so we will calculate it by looking at 400 minus actual cost of work performed, which is 500, right? Likewise, this minus 200 is calculated by looking at 900 take away actual cost of 1100, giving you a answer minus, and minus 50 by looking at this value 150 take away the actual cost of work performed, which is 200 from here, giving us an answer of minus 50. And then we will use this to represent this as a percentage. So we can see again, so if we take this example minus 25 and how it is calculated, so it's minus 100 cost variance divided by BCWP, which is 400, giving us minus 25, and minus 22 will be calculated by dividing minus 200 divided by 900, and this is will calculate by dividing minus 50 divided by 150. So we can see that in terms of a time we were okay, but in terms of a cost we are performing bad. Here we had a negative answer in terms of a schedule and negative answer in terms of a cost, and again schedule variance minus 50 and cost variance minus 33. So lastly, we are interested to calculate what is the estimated cost of completion. So if we continue with the same, how long will this project take us to complete? So this is calculated using this formula, which is actual cost of work performed divided by percentage complete. So basically we know here from here 100 divided by 100, so it is estimated cost of completion would, because this work has already been accomplished, so we do not expect that the cost would rise anymore. Over here, let's see how this 500 is computed. So we have actual cost of work performed, which is 500 here, divided by percentage complete, which is 100. So estimated cost at completion is showing as 500. We will calculate. So for instance, it's 1467. We can see the actual cost of work performed for activity 3 is 1100, divided by 75% percentage completion will give us an answer of 1467. So we will calculate the estimated cost of completion using this method, giving us a final cost of 3067. So initially it was 2500, and the final completion cost is looking at, based on the progress being reported on month 4, it's looking at 3067. Right. So this example serves as a illustration of the method which is used to compute the earned value analysis.